Okay, for the second video, for this part, it's going to be the same thing, except we're going to be just focusing on radian mode. So the first thing I want to do is review the, like when we're given a reference angle, how to get to an angle. So this doesn't change. So the reference angle equals the angle in quadrant 1. But instead of like in quadrant 2, the last video we talked about like 180 minus the angle, now it's going to be pi minus the angle and pi plus the angle. And then instead of 360, we're going to say 2 pi minus the angle. So kind of keep that in mind when we're doing these reference angles. Also, right now, we don't need it right this very second, but go ahead and grab your calculator and you're going to be using radian mode. So a lot of times I'll keep it in degree mode to start out, and I'll kind of explain that why later. But really, it needs to be at the end of the day, it needs to be in radian mode. Okay, so I want to go back and do this. So this is the exact same thing. Why don't you go ahead and do that and do this one and see how you do. Just think about it's going to be in radians. That's the only difference. So I'm going to push pause, see what you can do. Okay, so hopefully you got these answers here. So let me go ahead and kind of talk about my thought process, just in case you're not following. Again, if you're having issues, go back to that first video. These are exactly the same. The only difference is instead of giving it in degree, we're getting it in radians. So this is, well, first of all, I know that cosine inverse lies in quadrants 1 and 2. I also know that this is negative, so I'm just focused on the quadrant 2. I also figured out that that 1/2 is my reference angle is 60. So just like for my hand trick, that's all I did there. And so I knew 60 was something over 3. That kind of, I always kind of double check myself just to make sure that I don't have mistakes. So you don't have to know that. You can just like cheat and use your unit circle. So I know quadrant 2, 60-degree reference angle, and so I just looked there. You can also, use your x value as well. So anyway, you end up with 2 pi over 3. And cosine is negative in all 4 of the quadrants, in quadrants 2 and quadrants 3. So guys, get used. I know you're like, I don't need to do that, but we're going to need to know this. Like that's that process. It's kind of like in basic algebra when you do like 2x equals 6, you're dividing by 2 to get rid of it. That's what I'm doing right here. I'm like, that's that process. Okay, so again, I'm just using my unit circle here. Same thing. So 60-degree reference angle in quadrant 2 or my x value in quadrant 2. That angle is going to be 2 pi over 3, and then in quadrant 3, it's 4 pi over 3. So see if you can remember how to do it for the reciprocal function. So I'm going to push pause and see if you can get that one. Okay, so I went through the same process really as up here, except I just flipped it. So again, this is where I'm most comfortable with. So I just said instead of cosecant inverse of 2, I did sine inverse of 1/2. Other than that, it's the same. And then over here, again, I went through that process. Cosecant inverse of 2 is the same as sine inverse of 1/2. So notice that's the same thing as over here. I noticed that sine is positive in quadrants 1 and quadrants 2. So that kind of guided me where I needed to go. Okay, so for this next part, you might look at this and say, oh, 1/2, I believe that's on the unit circle. But cotangent is not. So this is kind of a sneaky snake one. So the first thing I want to do is just go through that process. I'm going to change color too. I'm going to go through that process and write it out with the inverse. Like that. So once you realize, and I don't know, this is my thought process. Once I realized that that this, I'm going to have to type this in my calculator, I went ahead and changed it for my benefit to tangent inverse of 2. Just so remember, cotangent, you just can't push a button on your calculator. So I went ahead and looked at it like that as well. And so I'm going to type this in my calculator. So guys, here's the thing. Go ahead, I'm going to show you, keep it in degree right now, and go ahead and type it in as tangent inverse of 2. Okay, so notice that it is 63 degrees. So that's still in quadrant 1. Sometimes you just have to be careful when you just have this random like radian number. You just need to make sure that it's in quadrant 1. So another thing you can do is just take like pi divided by 2. And so it needs to be less than about 1.57. So as long as you're okay with that, you're fine. Most of the time, you're fine. It's just like some weird things that happen. Okay, so I'm going to go ahead and switch it to radian mode. And I'm going to do tangent inverse of 2. So that ends up being about 1.11. Okay, so don't forget that this is your reference angle. So I'm dealing with, let's see, tangent. So let's go over here. So tangent is positive in quadrants 1 and quadrants 3. So those are the 2 quadrants that I'm talking about. So in quadrant 1, we already have that. So it's 1.11. But in quadrant 3, what I'm going to have to do is I'm going to have to take pi plus 1.11. And so that's going to give me 4.25. And that's my answer in quadrant 3. Okay, so in number 4, the first thing you're going to want to do, notice all this junk out here. So you're going to want to get sine by itself. Okay, so think about just algebra here. So I'm going to subtract 2 and divide by 5. So I have sine of theta equals -2/5. Okay, now it looks more like something like this. So I'm just going to type this in my, well, eventually type in my calculator. But I'm going to write this out first. So that's what I'm typing in my calculator, because this cancels out. Okay, so make sure it's in radian mode. And we're going to do sine inverse. And remember, guys, I always do the positive to get that reference angle. You do not have to do that. That's just like a little trick I personally do. So I know that my reference angle is 0.64, let's call it 0.644. I don't care where you round off. I round off at random places for some reason. Okay, so let's go back. And I know that sine, so this is my actual angle, even though I use the positive to get my reference. So I know that sine is negative in quadrants 3 and quadrants 4. So what I'm going to do for quadrant 3, I'm going to take pi plus 0.644, and here I'm going to take 2 pi minus 0.644. So in quadrant 3, I ended up getting 3.785, and in quadrant 4, I get 5.64. Okay, so make sure you're getting those values as well. Okay, so finally, last one, number 5. Let's do this in a different color. Let's do purple. So I'm going to do the same thing. I'm going to get like that cosine by itself. So I'm going to subtract 6 and divide by 2. Okay, so something should be jumping out at you. Cosine is bigger than 1. So remember that sine and cosine cannot be over, and I don't care about this. Remember, it's just like the 2.5. That can't be over 1, because that means that my hypotenuse is smaller than my adjacent side. So this is no. And that's it.